Today we are going to start with the new chapter, that is heat, light and sound. Now, before we begin with this, you can see from the book that Mr. Einstein, could you please lead us through a current topic of heat, light and sound? After all, you were a great physicist. My word. Now, let me tell you a very interesting thing about Einstein, Newton and Bill Gates, which is common. And the thing, yes, Bill Gates, the living legend, Bill Gates, yes, which is common to the three of them is that they were all school dropouts. They would never study. Yes. So now you know that they were all school dropouts and they never studied. So I guess this is the time when you are not going to the school. Use that X factor in your brains to promote your studies even further. You know, you can do miracles right now. Now is the time to do the miracle act. So be the Einstein of your world, like Newton. If an apple wouldn't have fallen on his head, he wouldn't have done anything. And if Einstein wouldn't have thought of riding a bicycle on a rainbow, then he wouldn't have thought of the theory of relativity, or that we can go to the future or to the past or to the future also. And if Bill Gates hadn't been a school dropout and he wouldn't have used his father's useless computers, we wouldn't have been making new coronaviruses like he has been doing nowadays. So now is the time to use that X factor for your work. So today we are going to start with heat, light and sound. So what is heat?
Heat is a form of energy.
Where does all the form of energy comes from on earth?
The sun.
The sun. The sun is the source of energy. And what can we make heat? Can we form energy? No. Energy cannot be formed or destroyed, right? So now today we are going to talk about conduction. Conduction is a process whereby the heat is carried. As you know that heat can be carried from one place to another easily. How can you do that? You can take an example of a needle or a chimta in the flame, and tweezer, or you talk about a skewer inside the flame, and the other end of the flame you can other end of the rod you can hold it with your hand if you have a flame going around, and then you poke a rod inside the flame. Slowly you grip this pen with your hand, and you will find out that this spike has become hot also. What actually happens is each rod or metal that you are holding in your hand is made up of atoms, as we already know. When these atoms gain energy, they start vibrating. When this one vibrates a lot, it starts making the other one vibrate also, and in the other one and the other one, and keep on going until that vibration reaches in the form of heat to the hand that is holding that rod. Is that clear? So that is conduction. You can also say that if in a line all students are sitting together, one beside the other, and I tell them to pass the duster from one person to the other until the duster reaches the last student, that is also a form of conduction or energy transfer. So these are all actually conduction, convection and radiation. They are all types of energy transfer. How does the energy transfer from one end to the other end? This is one form of energy transfer, whereby the particles keep on transferring or giving away their heat from one atom to the other until it reaches the person who is holding that that rod or whatever is in the hand. Now the second one is convection. As you can see, the convection is even more, it's a little bit more common to see in everyday life. Now if you know that lighter things always rise, have you ever heard of the floating lanterns of what was that cartoon in which they were floating? Rapunzel.
Yeah.
Yeah. Do you remember
Yes.
the cartoon? Okay. So in that, what do they do on a cold night? They fill that lantern up with the hot air produced by that burning candle. And when that, because the paper is so light, it starts lifting up. The hotter the air is, the more it will be easier for the particles to rise.
We can do the same thing with the tea bag.
You can do the same thing with the tea bag. What you do is simply take an empty tea bag and cut it, open it from both ends and unroll it. It will become something like this. Put it on a table, straighten it like a pillar on a table and light it from the bottom. Put fire on the bottom. What will happen? It will catch fire and slowly the flame, the hot air from the flame will rise inside the tea bag, and you will see that the tea bag is starting to rise in the air to the top of the shelves or whatever. It can be dangerous. You can do this experiment by yourself at home. We have done this also and it's very interesting. Javeria knows that. Okay? Yes. So hot air rises. That means hot air rises and cold air remains below. That is why, have you ever noted that a person who is sitting upstairs has or has a house which has an upper floor and a ground floor, then it is hotter in the upper floor while it remains cool in the ground floor, because the air is cooler in the ground, near the ground. And that is why during the summer season, when you are feeling very, very hot, you like to lie down on the floor because it is cooler, isn't it? And whenever your mom or the maid cleans up the room and mops the floor, you say, the floor is so cool, let me lie down and wow.
But what about the northern mountains? The top is more cooler.
So still the top, because it has frozen by that time, that is a different matter. We will talk about it later on. If you look at this in this way, that you are living in near the seaside. Karachi is near the seaside, right? Now during the summer season, the solid becomes more hotter than the liquid. You know that, because liquid is a good conductor while solid is not. So at night also the ground is so hot. If you look at this, if you assume this to be, this is the sea and this is the land, what will happen? The sea air will be cooler and it will be very cool, while the hot air in the near the land will be so hot that it will quickly rise up. When it will quickly rise up, there will be a kind of vacuum created over here. This vacuum will suck in the cool air of the sea, and this warm air will go to get cooled down to the sea, and in this way it will form a kind of circle, continuously wind moving. This is a convection current which keeps on moving. The hot air rises up, it goes to get cooled, and the cool air comes in from the sea, and this is known as summer and winter breezes during the near the sea area. So this is known as convection current. You can also see this. What you do is take a pot and put it on the stove, okay, and put water inside it and a piece, simply some specks of black pepper. Now when you heat it from the bottom, what will happen is you will see that all the black specks of the black pepper will rise up and they will come to the side, and then they will go all by the side, and they will come again from into the center, and then again they will rise up and come down from the sides. This is also a convection current. How this particle is taking the heat from the bottom and rising up and taking the heat all and distributing it all wherever they are going. It's just like if now if I tell you that one person is sitting next person to the next person to the next person to the next person to the next person to next person, when you pass this energy to this energy, one duster to the other duster, and then this second person takes that duster to gives it to the third person, and that third person takes the duster and gives it to the fourth person. This is conduction I told you about. But what about convection? If you talk about convection in here, this person will get up, take the duster, and move and go all the way to the last person without giving it to this one. He will simply distribute the heat to the last person, and this is known as convection. And it normally, yes, it is way more common in liquids. Very good. Liquids and even air.
Yes.
Liquids and gases. Okay, the third one, then we come to the third one, and that is radiation. Radiation is the direct transfer of heat from one side to the other side without anything needed. No person is needed, no particle is needed, no particle movement is needed, nothing is needed. The heat directly travels, just like the sun. There is vacuum between the sun and the earth, but still the heat from the sun still reaches a person. It still reaches a person who is standing on the earth. Why? Because radiation does not require any
So it's like
particle to transfer it. It's just like if there are 2 or 3 people standing side by side, you simply throw the duster from one side to the other. It will reach the other side without the use of any person moving or transferring the duster from one person to the other. So this is radiation. So this to stop radiation is much more easier. Why? Because just put a slate over there, or a paper, or a chart, or a hut, or build anything barrier between them, between the heat that is coming and you, and it will stop. Go into under the shade of a tree. The tree's shade is enough to protect you from the heat. So protecting yourself from heat radiation is easier. Now I would like you to do this question. Can you tell me, please? This person is being heated by conduction, convection, and radiation. Which is which? This person is simply putting his hand in front of the heat. What is this kind of heat transfer?
This is this is radiation.
This is radiation. What is this?
Conduction.
This is conduction. Okay. What is this?
And both these are the same thing.
They are the same thing. They do look
Aren't
the
there
same
particles
thing.
in air?
But
There are
see,
particles in air. So
yes.
this is not radiation.
No, there's
There
no.
are particles in air.
There are particles in air, but this one is radiation, I think, and this one is convection, because this one is moving like sideways. Maybe the person might be holding some form of something, or wet, or maybe might be the wetness of the
Going like
hand.
this, right? Isn't this because look at these arrows? They don't have the
Dotted ones. So the dotted ones are not the direct transfer. It might be the steam that is from the rising and getting to the. So this is convection, this is radiation, and this is conduction. A is convection,
convection,
C is radiation, and B is
conduction.
So this one was easy. You can all do this. Okay, name the 3 ways that heat can be transferred from one object to another. Explain. That is conduction, convection, and radiation. What are the 3 ways? These are the 3 ways in which heat can be transferred. Explain how it is transferred through these material, giving These methods giving examples. Okay, I have given you 2 or 3 examples. You find out another way of any example other than mine, and write them down. Can you give me some examples that you have in your mind for conduction other than mine?
Conduction. For example, there's a doorknob which has been heated, like because of the sun. You touch it, it's hot.
Yes, you after some time it becomes so hot when the sunlight is falling continuously on the doorknob. Okay, that's conduction. Another example, very good one. What about convection?
Convection.
Okay, you gave me that pot and black pepper example. That was a good one. We will take that one. And the third one,
The term radiation. That's a solar system.
you can simply sit near the fire.
Yes.
That is also radiation,
That's all.
isn't
all
it?
radiation.
Or what you can do is take a mirror and focus the sunlight on somebody
Okay.
else,
And the
and that person
magnifying
might
glass too.
never know. You know, there are many funny YouTubes on that. Somebody has a person was simply sitting and doing nothing, and from the back another friend of theirs you know, yes, reflected the sunlight onto their back, and they started feeling hot at the back. They didn't understand what was going on because they are not doing anything. So you can think of many other ways. This is another way of explaining this radiation. Now let's see about this activity that we have. Let us see what this activity actually says. This activity shows that metal conducts heat at different rates. Metal rods of iron, copper and brass. You can take different metal rods. You can take a ruler. There was a ruler somewhere here. Okay, where is it?
I think.
Okay. Okay, you can take a metal rod, a ruler like this, or you can take another wire from like this one. I've got wires over here. You can remove the plastic coating from the wire and use these copper wires for and then what you do, yes, rods. You can take these rods and different types, or you can take the inside. Have you seen that broken lock? There is a small rod that comes out of the broken. You can take that also. And Bunsen burner and tripod stand. We don't have a tripod stand. Even there, you can take a cup stand that is made of metal. You can, like this one. I will show you in a minute. This one, like this one. This is a metal cup stand. You can use this stand for instead of a tripod stand. Okay, there's it will do the same work. Let's see what they are actually saying. What you will do, place the rod on the tripod stand, remember which is which, and place 3 drops of wax on equal distance along each rod. Place the Bunsen burner under the tripod stand and light it. Time how long it takes for each drop of wax to melt. As each drop of wax melts, you know the heat has been transferred. Now what you are going to actually do is you are going to take this stand, let this stand be, and put the burner under it, or take under it. What you do is you take a candle wax, okay, and on top of this ruler, what you do is you put a drop of wax over here, and over here, and when the candle is burning, you put this on top of it and see how long it takes for all the wax drops that you have put along the ruler to melt. In this way, you will know on steel how long it takes. Then you take another rod made of copper, or another rod made of brass, and see how long they take to form this. As each drop of wax melts, you know that the heat has been transferred to that part of the rod. Take note of which metal are better conductors of heat and which one are not so good. This is awesome. So up to now we will be completing only this much, and let's see if you can complete all these exercises in the try doing these experiments at home and see what you come up with. And do let me show me share your views and experiments on the WhatsApp, so that I can be sure that you have tried to do this. Okay, and do let me know about this exercise also, and write this down on on your register. What 3 types of experiments you consider
And that
best?
bag one.
Yes, try that tea bag one, in which the convection current goes. Okay, so that would be interesting. So if you like, you can subscribe, like, and share my video also.